Why does a rubber band stretch easily, but concrete cracks? Why can steel carry massive loads without failing? And what actually happens inside the materials if a force is applied? Today, we are learning the two concepts engineers use to answer these questions: stress and strain. Welcome back to DMS Engineering Hub. In the last episode, we introduced the strength of materials, the science that helps engineers design safe structures. But today, we go deeper into the language of materials themselves. Let's start. When a force acts on a material, the material reacts internally. If you pull a bar, it stretches. If you push it, it shortens. And if the force becomes too large, the material may fail. Inside the material, internal invisible forces are resisting the applied load. Engineers call this internal resistance, which means stress. By definition, stress is the internal resisting force per unit area inside a material. It is given by this formula, which is sigma equal to the force over area, where sigma is the stress, F is the applied force, and A is the cross-sectional area. These equations tell us something very important. A large force acting on a large area may be safe, but the same force acting on a small area can become dangerous. When forces pull a material apart, we call it tensile stress. For example, bridge cables, rope, or crane wires. When forces push inwards, the material experiences compressive stress. For example, concrete columns, walls, or foundations. When forces slide one layer over another, shear stress occurs. For example, bolts, rivets, and cutting tools. Stress describes internal force, but strain describes deformation. In simple words, strain measures how much the material can change its length or shape. It is given by the following formula. If a steel bar becomes longer after being pulled, strain tells us exactly how much it is stretched. If engineers do not calculate stress correctly, structures can fail. Too much stress may cause cracks, permanent deformation, and collapse. That is why civil engineers must understand how much materials behave under load. Today, you learned the two most important concepts in strength of materials: stress and strain. Every bridge, building, machine, and structures depends on these principles. If this video helped you understand stress and strain clearly, subscribe to DMS Engineering Hub and continue your engineering journey with us. In the next episode, we will learn about elasticity, plasticity, and Hooke's law, the science behind how materials return to shape.